Section 1.7, functions. This will be your last instructional video for Chapter 1, and it is probably the most important section that we will do all year, because talking about functions is what our year is going to be about. Almost everything that we do will relate to a function in some form, and you will see that come up throughout this year as we move forward. So your goal is to identify a function and make an input-output table for a function. Here's some vocabulary. A function is a rule that establishes a relationship between an input and an output. And this is important. For each input, there is exactly one output. That is what makes it a function. The domain is a collection of all of the inputs. So those are all of your values that you input as you go along. And we're going to repeat that as we go throughout this instructional lesson. The range is a collection of all outputs. Now please note that this is different than statistical range. Statistical range is the difference between your highest and lowest values. That is not what we're talking about when we talk about functions. The range is all of your output values. So it's going to be a list just like your domain. And then your input-output table is a T-table. It lists all of your inputs and your outputs. You're going to hear us refer to the rule of 3 plus 1 quite a bit this year. There are 4 forms of functions. There's the T-table, there's the graph, there's the algebraic, which we have talked about a lot so far in our instructional videos and in class, and then there are the verbal, which we have again talked a lot about as we've gone through the last couple sections. The rule of 3 plus 1 means that if I give you a graph, by the end of the year you will be able to create a T-table, the equation, and the verbal explanation of what that graph represents, or T-table. Or if I give you it verbally, like we practiced going verbal to algebraic in the last instructional video, if I give it to you in verbal, you should be able to create it algebraically, you should be able to create a T-table for it, and you should be able to graph it. And by the end of the year, you will be able to switch between each of these forms. If I give you any one of them, you should be able to, without hesitation, switch to the other 3. And that's really what we're going to be working toward as we get through our algebra curriculum this year. So, first of all, we're going to determine if these are a function or not. We said that a function has exactly one output for every input. These are 3 different input-output tables. Your input is your x value, your output is your y value. So does every input have exactly one output? And the answer here is yes. We have 4 different inputs. So we have a function. When we look at the second one, your x value again are your inputs, your y values are your output. Does every input have exactly one output? And in this case, we can say no, because the input of 3 has an output of 2, an output of 3, an output of 4, and an output of 5. Even though it's listed separately each time, that input has multiple outputs. And so we would say that the second one is not a function. And then looking at the third T-table, where we have x and y, we want to know if every input has exactly one output. And the input of -1 has one output. -2 has one output. -3 has one output. -4 has one output. This one is a function. And you might be asking, well, why is this one a function and not the second one? Here, yes, all of your inputs have the same output, but each input has only one output. And the second one, your input of 3, has many different outputs. That one's not a function. All right, so creating an input-output table. When you're given an equation, this is the algebraic, all right, and then we're going to go to a T-table. So we're going to use -1, 0, 1, and 2 as your domain. In your homework, if it doesn't tell you what to use as your domain, which is your input, you're welcome to choose the values that you'd like. We'd like to see a minimum of 4, and generally speaking, it's good to have at least 1 negative. So we're going to use -1, 0, 1, and 2. So when I try to create the input-output table, I'm going to put -1 in for x. So is 2 times -1 minus 3. That's -5. 2 times 0 minus 3 is -3. 2 times 1 minus 3 is -1. And 2 times 2 minus 3 is 1. So what we're doing is we're evaluating expressions like we talked about earlier on in the chapter and applying it to creating a t-table from an algebraic equation. We're going to do the same thing with this next one. Y equals -3x. So -3 times -1 is 3. -3 times 0 is 0. -3 times 1 is -3. And -3 times 2 is -6, creating an input-output table. For tomorrow, we want you to determine if the following is a function or not and explain why you think that to be true. And then we want you to create two different t-tables, one where you're using, both of them using -1, 0, 1, and 2 as your domain. Have a wonderful evening, and we'll talk with you soon.